Today's video will take you inside a question that sounds simple until it breaks your intuition. Why the speed of light is not just a fast number, but the boundary that keeps the universe logically stitched together, and why every serious attempt to beat it quietly threatens cause and effect. This presentation uses a voice and style inspired by Richard Feynman, and the aim is to show you this the honest way, not with slogans, but with the kind of reasoning that survives a blackboard and a skeptical room. We'll move through several angles on the same mystery. A world where signals are instant, a history where the old ether story never died, a universe where the speed limit is smaller so relativity crashes into daily life, and the uncomfortable question of what really collapses first if you try to outrun the boundary. What makes this notable is that the limit isn't a rule taped onto nature. It's the price of keeping the laws consistent for everyone. Lately, I keep hearing people talk as if faster than light is just better engineering. Tonight, we're going to test that belief until it either becomes physics or it becomes nonsense. Now, let's begin where all the trouble starts. What you mean by the same time? Let me start with a confession. The first time most people hear nothing can go faster than light, they treat it like a traffic law written by a grumpy cosmic policeman, because the universe says so. That's not an explanation. That's surrender. I never like surrender. So let's do this the way I do it in a room full of sharp students who don't let me hide behind fancy words. We'll take the idea apart until it either breaks or it becomes unavoidable. Here's the hook. Imagine you wake up tomorrow and the universe has changed in one tiny way. Signals can travel instantly. Not faster than light. Just instant. You flip a switch in California and a meter in New York twitches at the same moment. No delay. No waiting. People would celebrate for about 10 minutes. Then physics would start screaming. Because when you say same moment, you're already assuming you know what same means. That's the real doorway into this story. The speed of light is not just about light. It is about how we are forced to define time. If you want time to be more than a feeling, you need a procedure. A clock. A way to synchronize clocks in different places. And the simplest, cleanest way to do that is to send a signal and assume it travels the same way every time. In our world, light is the best signal we have, and it behaves with maddening consistency. You can complain about it. You can wish it were different, but you cannot bully it into being faster for your convenience. Now here's the first, what if, I like to torture people with. What if Maxwell had never existed? Or what if his equations had been treated as a mathematical parlor trick and ignored by experimenters? Then we might have clung to the old idea that influences propagate instantly. We would have kept our comfortable Newtonian time, one global cosmic ticking that everyone shares, like an invisible metronome behind the stars. And we would have built more and more elaborate machinery on top of a false assumption, the way people once built epicycles on top of epicycles to save the heavens. But the trouble with nature is she doesn't care what makes us comfortable. If electromagnetic effects have a finite propagation speed, the universe doesn't give you the option of keeping absolute time. You can deny it, but your denial won't make your experiments agree with you. So we come to the next what if, and it's the one that actually explains the first. What if the speed limit were infinite, but we still insisted that the laws of physics look the same for all observers moving steadily relative to one another? Try to keep both. You can't. If one person sees a signal move instantly, another person moving relative to the first will not, unless you let time and distance do something very strange. And once you let them do that, you are already halfway to the world we live in. That's why I always tell students, stop thinking of the speed of light as a speed limit sign. Think of it as a conversion factor between space and time. It's the number that tells you how many meters correspond to 1 second in the way the universe is stitched together. Now, let's make the story more vivid. Suppose you and I are standing far apart with clocks. We try to agree on what now means. We send flashes back and forth. If the flashes don't have a stable speed, we can't build a coherent map of events. Our measurements dissolve into argument. But if there's a universal signal speed that behaves the same way in every direction, then we can synchronize, coordinate, and do physics. So here's the best-case scenario hidden inside the harshness of the limit. The universe is not arbitrary chaos. It gives us a stable structure that allows reality to be logically stitched together. Now I want to push you into a deeper corner with a third what if. What if you could push a massive object all the way to the speed of light? People imagine this like a car engine. Just add more fuel, go faster. But that picture fails because it assumes time is a background stage, not a participant. As you push something faster and faster, you are not just changing its position. You are changing how its motion fits into spacetime. The closer you get to that special speed, the more violently the bookkeeping of energy and momentum rebels against you. You can keep paying, but the price rises without mercy. It isn't a mechanical resistance like air drag. It is the structure of the equations themselves. And that's why, in our world, light is not a runner approaching a finish line. Light sits on the line. It lives on the boundary. Everything with mass lives inside. Now, if you've followed me so far, you should feel a kind of tension building. Because if this limit is tied to the definition of time, then breaking it doesn't merely mean going fast. It means tampering with cause and effect. And that's where the story gets dangerous. Because once you allow a signal that beats light, you don't just win a race. You invite a paradox. Not a cute philosophy paradox. A physics paradox. A situation where one observer can arrange events so that an effect happens before its cause, while another observer insists the opposite, and both are using the same rules you told them to trust. In other words, you don't get a better universe. You get a universe that cannot keep its story straight. So the next step is to face the real question head-on. If faster-than-light signals make causality wobble, how exactly does the universe prevent that wobble while still letting every observer claim the laws are the same? That's the point where the simple speed limit phrase stops being a slogan and becomes a necessity. If this made your brain itch in a good way, pass it to your classmates and friends and tell me in the comments what you think would break first in a world with instant signals, time, logic, or our sanity. All right, let's poke that itch properly. With absolute confidence, that faster-than-light signals would be awesome. Imagine you invent a little gadget that sends a message faster than light. Not a big message, just one bit. A yes or no. A blink. You hand one to your friend. Keep one for yourself. And you decide to test it in the most innocent way possible. Now comes the trap. The moment you say, we'll test it at the same time, you've already stepped onto the mine. Because same time is not universal. It is something you construct with a method. And the method relies on signals. If your new signal breaks the old rules, you don't just gain a new tool. You corrupt the very definition you were using to claim your test. Makes sense? So let's explore a few alternate histories, because they make the point sharper than any lecture. Imagine a world where the 19th century had gone differently. Suppose the Michelson-Morley experiment had found a clear ether wind. People would have cheered. They would have said, "Good, the universe has a preferred rest frame." Time would have stayed universal, at least in everyone's minds. In that world, the speed of light could still be a property of the medium, like sound in air, and there would be nothing sacred about it. The limit might still exist as a practical constraint, but it would not be welded into the logic of causality the same way. You could imagine a different carrier, a stiffer medium, a faster wave. Physics would become a story about materials, not geometry. But our world didn't give us that escape hatch. The ether idea didn't die because it was ugly. It died because nature refused to cooperate. Now imagine another fork in history. Suppose Einstein never wrote his 1905 paper. People love to turn history into a single hero narrative, but that's lazy. The real pressure was already building. The equations were cornering everyone. If Einstein had decided to become a violin teacher, someone else would have had to clean up the mess, because the mess was real. Lorentz, Poincaré, and others were already circling the same strange conclusion. The laws were telling us that time and space were not separate bookkeeping categories. They were coupled. In that alternate history, the name on the paper changes, but the logic does not. That's an important lesson. The speed limit is not a cultural choice. It is what happens when you demand consistency. Now for the alternate history that really makes your head spin. Imagine a universe exactly like ours, except the invariant speed is 10 times smaller. Not the number in meters per second. Forget the units. I mean the fundamental conversion between space and time is lower. In that world, Relativity is not some exotic effect you need particle accelerators to see. It barges into daily life. Your car's GPS would need huge corrections. A fast train would noticeably age its passengers differently from people standing on the platform. Engineers would grow up with relativity as a practical craft, the way we grow up with Newton. Here is the punchline. In that world, nobody would ask, "Why is there a speed limit?" They would ask, "How did anybody ever believe there wasn't one?" The limit would feel as normal as gravity. Now let's flip it. What if the invariant speed were enormous? Then relativity becomes almost invisible again. That's close to our situation. We live in a universe where the speed is so large compared to our ordinary motion that we get away with naive thinking. And because we get away with it, we mistake our convenience for truth. So when someone tells you, "Light is special," I want you to hear the deeper version. The structure of spacetime is special, and light simply reveals it. Now let's return to your faster-than-light gadget and push it into the harsh light of logic. Suppose you and your friend are moving relative to each other, and you use your gadget to send that one bit. In your frame, you send it. Then they receive it. In another frame, because simultaneity is not absolute, the ordering can flip in a way that lets the received message appear to arrive before it was sent. Once that door opens, you can build a loop. A message that prevents itself from being sent. A no that causes the yes that causes the no. The universe doesn't merely get confusing. It becomes inconsistent. And don't try to rescue it with, "Well, maybe it only works sometimes." If it works for even one inertial setup, the symmetry of the laws drags the paradox in behind it. That is why the limit is so stubborn. It's not protecting light. It's protecting causality. It's protecting the possibility that the universe can keep a coherent ordering of events for everyone, even when observers disagree on the slicing of time. Now here's the best-case scenario I actually like, because it turns the whole discussion from frustration into appreciation. The speed limit is the universe giving you a reliable framework. It says, you may move, you may accelerate, you may disagree about time and distance, but if you follow the rules, you will not be able to manufacture contradictions. That's generous. A sloppy universe would let you build nonsense machines. A disciplined universe stops you. So if you want the real, what if that's worth thinking about? It's not. What if we beat light? It's what if the universe did not enforce a clean boundary between what can influence what? Because then science itself collapses. Not because we'd be sad, but because explanation would stop working. If you're enjoying this, share it with your classmates and friends, and tell me one thing. In a world with a smaller invariant speed, what everyday activity do you think would become the first place people notice relativity without being told it exists? In a universe where the invariant speed is smaller, the first place you would notice relativity would not be in a laboratory. It would be in the simplest human habit of all, trying to agree on what time it is. You wake up, you look at a clock, you trust it. You call someone across town. You assume their now matches yours. In our world, that assumption is mostly safe because we move slowly compared to the cosmic inversion between space and time. In a world with a lower limit, that trust would become a daily engineering problem. You would not be able to ignore it any more than you can ignore the fact that water runs downhill. So here's the best-case scenario in that alternate universe. Society becomes honest. Not morally honest, measurement honest. People would grow up knowing that at the same time is something you build, not something you inherit. Every trade, every train schedule, every long-distance phone call, every power grid handshake would have to reckon with the reality that simultaneity is local. You'd get a public that is scientifically literate in the only way that matters. They would understand what words mean operationally. Now let's imagine two different historical paths inside that same lower-speed universe. In the first path, governments and engineers figure it out early because they have to. Railroads become the first big battlefield. In our history, railroads forced time zones because local solar time was a mess for scheduling. In that alternate history, railroads force a deeper revolution. You can't just standardize time by decree. You have to standardize synchronization procedures. You would see entire professions built around clock networks, signal correction, and what I'll call practical spacetime bookkeeping. It would be as ordinary as accounting. And here's the twist. Because the corrections would be large and obvious, they'd become part of cultural common sense. The way people today casually understand that a bridge expands in heat. People that would casually understand that motion changes the mapping between time and space. In the second path, society stays stubborn. They cling to absolute time because it feels right. The way people cling to bad economics because it feels fair. Then the technology starts failing in humiliating, expensive ways. Communications networks desynchronize. Navigation becomes unreliable. High-speed transport becomes a recurring scandal. You can picture committees yelling at each other because the clocks disagree, as if the clocks are misbehaving children, when the real culprit is that their worldview is wrong. In that path, relativity becomes politically irritating before it becomes intellectually accepted. And that's believable, because humans always try to treat a fundamental fact as if it were a policy choice. Now let's get concrete, because I don't trust explanations that can't be tied to something you can picture. Take navigation. In our world, satellite navigation only works because you correct for relativistic effects. That's not philosophy. That's engineering. In a universe with a lower invariant speed, you wouldn't get to treat those corrections as a footnote. Navigation would be the loud daily reminder that time is not universal. If you tried to build a navigation system while pretending otherwise, you'd send people into the wrong neighborhoods, or worse, the wrong oceans. So the best-case scenario is that this pressure creates a new kind of engineer, someone who thinks geometrically about events, not sentimentally about clocks. Now take communication. People fantasize about faster-than-light messages because they imagine it would make life simpler. It's the opposite. In a world where the invariant speed is smaller, communication forces you to confront delay as an unavoidable feature of reality. If you send information, you are sending a physical influence, and it takes time. That lesson would be baked into every business decision. You'd see organizations designed around latency. You'd see entire institutions optimized not for speed, but for consistency. And that's interesting because it flips what people usually admire. We admire speed. That world would admire coordination. Now let me offer you a what if that's actually worth chewing on, because it's not about breaking the limit, it's about using it. What if the universe's speed limit is not a prison, but a stabilizer, like the rigid frame of a machine? In that best case, the limit is what makes reliable law possible. It keeps cause and effect from turning into a mess of contradictions. It gives you a clean boundary between what can influence what and when. Once you accept that boundary, you can build astonishing things on top of it because you're not fighting the structure of reality. That's why I'm always suspicious of the question, why can't we go faster? It's usually asked by someone who hasn't noticed that the universe is already giving them a consistent stage on which any explanation can even happen. So here's the thought-provoking end I'll leave you with. If you lived in that lower speed universe, you would not romanticize faster than light anything. You would fear it, the way you fear a crack in the foundation of a building. You would realize that the moment you let influences outrun the boundary, you risk turning explanation itself into nonsense. And if you live in our universe, the quieter lesson is the same. Stop thinking of the speed of light as a limit that steals your dreams. Think of it as the rule that keeps your dreams from collapsing into contradictions. Share this with your classmates and friends, and tell me this. Would you prefer a universe where relativity is obvious and unavoidable in daily life, or a universe like ours where you can ignore it most of the time and still get away with sloppy thinking? If you're tempted to pick the universe where relativity is obvious, I understand the impulse. You want clarity. You want the truth to shout so loudly that nobody can pretend it isn't there. But here's my hook for the last stretch, and it's a little uncomfortable. The universe we have is already shouting. You're just used to the volume. We built a civilization on approximations that work only because the invariant speed is so large compared to our daily motions. That's not a flaw in nature. That's a kind of mercy. It lets you live your life without doing Lorentz transformations on a grocery list. But it also creates a cultural trap. You start believing the approximation is reality itself. You mistake good enough for true. So if we want the best case, it isn't a different universe. It's a different habit of mind. Let me tie the whole thing together in one clean picture. At the start, I asked you to imagine instant signals. The appeal was obvious. No delay, no waiting, no distance in communication. But the minute you try to describe what instant means, you discover you were leaning on a hidden assumption, that there is one universal notion of same time. Once you drop that assumption and demand a procedure for synchronizing clocks, you are forced into the world where a single invariant speed defines the geometry of events. Then we wandered through alternate histories, because they show what is essential and what is accidental. If experiments had blessed an ether, you might have kept absolute time. If Einstein hadn't written his paper, someone else would have, because the logic was already tightening. If the invariant speed were smaller, relativity would become everyday engineering. If it were larger, you could ignore it even more than we do. Across all those variations, one thing kept reappearing like a stubborn character in every story. You cannot have consistent laws for all observers without paying the price in how you treat space and time. Now, what's the price? The price is giving up the childish picture that time is a universal river flowing the same way for everyone. Instead, you accept that time is part of a four-dimensional bookkeeping system that must remain self-consistent when different observers compare notes. The invariant speed is the glue in that bookkeeping. It tells you what counts as causally connected and what does not. That's why, when people daydream about faster-than-light travel or messages, I don't roll my eyes because I'm a killjoy. I roll my eyes because they are asking for a universe that cannot keep its statements consistent across observers. They are asking for the right to build a contradiction and call it progress. And now comes the most useful what if to end on, because it doesn't require you to violate anything. What if, instead of trying to outrun light, you try to design your thinking around the light cone the way a good engineer designs around stress limits? In that best case, you stop treating delay as a nuisance and start treating it as structure. You stop imagining causality as a vague philosophical idea and start treating it as a concrete constraint that makes explanation possible. You stop asking, why can't we go faster? And start asking, what does the universe allow that we're not clever enough to exploit yet? That shift matters because it changes how you teach, how you build, and how you argue. It changes how you teach because you don't begin with formulas. You begin with meaning. You ask, how do we know two events are simultaneous? How do we synchronize clocks? What do we mean by measuring a distance? You make students confront that physics is not a set of facts. It is a disciplined language grounded in operations. It changes how you build because you stop pretending that only the laboratory needs deep physics. Navigation, communications, distributed computing, high-speed transport, even the stability of power grids all depend on timing. And timing depends on how you define time. In our world, the corrections are small enough that many people can ignore them until a system fails. In a lower-speed universe, you would learn early. In our universe, you have to choose to learn early. And it changes how you argue because it gives you a filter for nonsense. Whenever someone proposes a miracle, you ask a simple question. Does it preserve causal order for all observers? Or does it sneak in a preferred frame while pretending it doesn't? If it needs a preferred frame, fine, say so honestly. If it claims to keep all symmetries and also beat the invariant speed, then it's either wrong or it is secretly rewriting the foundations and calling it a feature. That is the coherent ending. The speed of light is not a random wall the universe built to annoy ambitious creatures. It is the boundary that keeps the universe logically livable. It is what prevents physics from turning into a choose-your-own-adventure book, where effects can be arranged to cancel their own causes. So here's my closing thought, and it's the one I want you to carry into whatever you build next. A disciplined universe is a gift. It means you can discover laws, trust them, and use them. The speed limit is part of that discipline. It is the quiet rule that lets every observer, no matter how they move, tell a compatible story about cause and effect. If this clicked for you, share it with your classmates and friends, and tell me what you think is more dangerous. A universe with faster-than-light signals, or a universe where people keep insisting their everyday intuition is the final authority on reality. When I was younger, I used to think the universe owed me an explanation that felt comfortable, something that matched the pictures in my head. But the longer you spend with real physics, the more you learn that comfort is not part of the contract. Nature gives you something better. She gives you consistency. That's what this whole story has really been about. The speed of light isn't a trophy for light. It's the boundary line that keeps the rest of reality from contradicting itself. It's the quiet rule that prevents you from building a machine that can send a message into its own past and then argue about whether it ever existed. You can be disappointed that you can't outrun it, or you can be grateful that the universe is disciplined enough to let knowledge accumulate without collapsing into logical noise. And there's something almost human about that discipline. You can feel it if you imagine a simple scene: a chalkboard at the end of the day, dust hanging in the air, a half-erased diagram of cones and arrows, and the strange relief that comes when the pieces click. Not relief because it's easy, but relief because it holds together. Because no matter how fast you run, no matter how you tilt your viewpoint, cause still comes before effect in the only way that can be shared by everyone. If there's a lesson I want you to keep, it's this: don't treat the universe like a wish list. Treat it like a puzzle with rules that deserve respect. Once you respect the rules, you stop wasting your imagination on contradictions and you start aiming it at what's actually possible. So here's what I'm curious about now, and I want you to be honest with yourself when you answer it. If someone offered you a universe with faster-than-light signals, but the price was that cause and effect could no longer be trusted, would you take that deal? Drop your answer in the comments and tell me why, because the why is where the real thinking lives. Thanks for watching. If you enjoyed this video, hit that like button, subscribe to our channel, and turn on notifications to stay updated on our uploads.